Welcome to The Explainer. Today, we're going to explore humanity's long and, let's be honest, terrifying history with natural disasters. And we're going to look at the deep-seated need we seem to have to record them. It is a journey that takes us from personal horror to planetary data. But first, let's talk about those moments when planets seem to line up, getting incredibly close in the night sky. We're going to break down what's really going on up there. I bet you've seen it yourself. You're looking up one night, and you see two super bright points of light way closer than they should be, and you think, wait a second, those aren't stars. That feeling of awe is exactly what we're diving into. It's a moment people have been experiencing for forever. Our game plan is to start with the sheer beauty of the celestial dance, get into the science of what conjunction actually is, check out the different planets and objects involved, look at some of the most mind-blowing alignments, and then zoom out for the big cosmic picture. It really does look like a perfectly choreographed dance, doesn't it? You can watch night after night as two planets slowly drift closer and closer, almost like they're waltzing, until they nearly merge into one brilliant beacon of light. It feels totally magical. But as magical as it seems, it's not magic at all. It is something way cooler: orbital mechanics. It's the beautiful, predictable clockwork motion of the planets, including our own Earth, orbiting the Sun. The official term for one of these cosmic meetups is an astronomical conjunction. While that sounds a bit technical with textbook terms like right ascension and ecliptic longitude, you can ignore the jargon. The only phrase you really need to focus on is, as observed from Earth. That is the absolute key, because a conjunction is entirely a trick of perspective. It's a line of sight event. The planets aren't actually getting close to each other at all. They just happen to line up perfectly from where we're standing. Picture it this way. You're on Earth, you look up and you see the moon. Now imagine that way out in deep space. The giant planet Jupiter happens to pass into that exact same line of sight. From your point of view, they look like they're right next to each other. What's wild about the illusion is that the moon is roughly 240,000 miles away, but Jupiter is over 400 million miles away. They aren't even in the same celestial zip code, but for a brief moment from our backyards, they look like they could touch. This celestial lineup can happen with all sorts of different dance partners. Moon and planet, the most common pairings, where our fast-moving moon cozies up with a bright planet like Venus. Planet and planet, classic planetary pairings, like when Mercury and Mars pass each other. Solar conjunctions, alignments that involve our sun. We need to draw a clear line between these things. An apparent conjunction is the beautiful one we see at night, when two objects look close together. A solar conjunction, on the other hand, is when a planet lines up directly behind the sun from our perspective, making it completely invisible, lost in the sun's blinding glare. To measure this closeness, astronomers use angular separation, the apparent gap between two objects in the sky. To give you some perspective, the full moon is about half a degree, 0.5 degrees, wide. On August 22nd, 2032, a predicted conjunction between Mercury and Mars will bring them to a staggering angular separation of just 0.376 degrees. An alignment this close is incredibly rare. You won't be able to tell them apart with the naked eye. They will just look like one single, blazing star. When you dig through historical data, you find other spectacular moments, like the incredibly close pass between Mercury and Neptune in 1945, or the upcoming 2034 alignment, where Venus and Mars will get close in the width of the full moon. It's amazing to see this intricate dance mapped out across time. How do we record disasters today? The approach has shifted dramatically from historical storytelling to modern data logging, from feeling the event to measuring it. Nowadays, we catalog catastrophes in spreadsheets and databases. Names that echo through history, Vesuvius, Krakatoa, are now organized by date, location, and quantified impact, like mapping the deadly pyroclastic flows, superheated, fast-moving clouds of ash and gas of Mount Pelee. It's a fiery ledger of our planet's most violent moments. This captures a massive cultural pivot. On one side, historical writers like Daniel Defoe focus on eyewitness stories and a hand of providence. On the other side, modern science zeroes in on precise data, death tolls, economic costs, and geological scales like the Volcanic Explosivity Index, VI. We pivoted from documenting to performing analysis because that analysis lets us build safer cities, write better policies, and save lives. This systematic recording is part of a coordinated global effort. Our universal drive to understand the world now has a global digital memory. We have detailed logs of Atlantic hurricanes going back centuries, tracking dates, locations, and even odd historical footnotes. like the 1766 hurricane that financially ruined the family of Napoleon's future wife, Josephine. Our gaze even extends beyond our atmosphere. We track threats from 93 million miles away, documenting huge solar storms and how they impact our technology, from setting telegraph systems on fire in 1859 to knocking out entire modern power grids. Organizations like the USGS and NOAA maintain these vast databases, creating a global ledger of our planet's power to understand a rhythm of risk on a planetary scale. But why do we compile these grim catalogs of destruction? The reasons are both scientific and deeply human. It is about survival and recognizing patterns to prepare for future, but it is also about memory, honoring those lost and finding meaning in a world filled with forces greater than ourselves. The mission of a modern scientist is not all that different from Daniel Defoe's. His goal was to convey a memory to the ages to come. Today we use data instead of poetry, but the core mission remains the same. This brings us to a compelling question. Are the great disasters of history truly random, or are they connected by a hidden rhythm in the cosmos? Our source material suggests a mind-bending idea. A 36-year cycle of Saturn-Neptune planetary alignments linked to major terrestrial disasters. Let's look at how the history blocks out across this 36-year drumbeat. 1700, Cascadia megathrust quake, falling right in the 1699 to 1703 planetary conjunction window. A monster magnitude 9.0 quake struck North America. This data point solved a massive geological mystery. Scientists use historical Japanese records of an orphan tsunami, a giant wave with no local earthquake. In 1700, it traced the wave back to this exact North American fault. 1737, Kamchatka quake, exactly one cycle later. During the 1735 to 1739 window, Russia's Kamchatka Peninsula was slammed by a magnitude 9.0 earthquake. The resulting tsunami produced waves reported up to 60 meters high, the height of a 20-story building. 1773, global activity window of the next cycle, 1771 to 1775, saw global tectonic activity. Japan was devastated by the Great Yaima Tsunami in 1771, while halfway across the world, the Santorini volcano erupted under the sea in Greece. 1883, the destruction of Krakatoa moving forward. The 1880 to 1884 window hosted a cataclysmic eruption of Krakatoa in August 1883. Notably, the 1882 planetary conjunction was the tightest alignment of Saturn and Neptune ever recorded from Earth. A year later, the planet experienced its most violent volcanic eruption, spawning 100-foot waves and killing over 36,000 people. 1952, Kamchatka repeats centered around the 1953 window. Kamchatka was struck again on November 4, 1952, by another magnitude 9.0 earthquake and a massive Pacific-wide tsunami. 1989, the Berlin Wall and Mount Pinatubo. In November 1989, the Berlin Wall crumbled. Less than 2 years later, in June 1991, Mount Pinatubo unleashed the second-largest volcanic eruption of the 20th century, altering global climates and dropping world temperatures by half a degree. A concrete political barrier, Saturn, dissolved at the same time a solid mountain dissolved into a chaotic veil of ash, Neptune. Is this a genuine cosmic rhythm, or is it just our human brains desperately finding patterns in chaos? Mainstream science views these events through purely terrestrial models like Coulomb stress transfer, which explains earthquakes as a physical chain reaction of mechanical stress moving down a fault line like falling dominoes. Using these metrics, seismologists successfully forecast a massive rupture along the Kamchatka subduction zone. Mainstream science also utilizes the Brownian passage time, BPT model. This model states that tectonic stress builds steadily, but random physical noise within the Earth's crust makes exact timing fundamentally unpredictable, less like a clock, and more like a leaky faucet where you know a drip is coming but cannot predict the exact second it falls. This sets up a fascinating clash between a tantalizing cosmic pattern and the scientific embrace of randomness. The next exact conjunction of Saturn and Neptune occurs on February 20th, 2026. Astrologically, it lands at the very beginning of the zodiac, signaling powerful, world-changing new beginnings. Historical analysis points to potential themes: challenges to global power structures, the redefinition of national borders, and the birth of a new global paradigm. If history truly does have a hidden beat, we are about to find out what song the universe is playing next.